Okay, start करें. Have you ever thought of a life without engines? Well, I don't think so we can imagine such life. Engines have become an important part of life. So, hi, I'm Harshika Raj and my application number is T004536. And today we are going to talk about the topic timelines of engines. So, let me give you a brief idea of our content which we are going to deliver now. So, firstly, I'll be giving you the basic information about engine, like what is engine and who invented it. Then we will be dealing with beginning a new era with engines, and after that, the generation of engines, like what were the engines in 13th century, 17th century, 18th century, 19th century, and 20th century. And after that, modern engines, atomic engines, drawbacks of present time engines, future aspects of engines, and lastly, the conclusion. So, what do you think? What is engine? Yes, it is a machine designed to convert one or more form of energy into mechanical energy. But it is a blessing because if it would not have been there, then we would still have been traveling on horses, camels, or other animals. There are mainly four types of engine: thermal engines, reaction engines, electrical engines, physical engines. And then the thermal engine is further subdivided into two parts: internal combustion engines and external combustion engines. So, now the question arises, who made engines? There were many scientists and engineers who contributed to the development of engines, but Samuel Brown was the first who made industrial engine in 1823. Now coming to the India's first engine, Vande Bharat, which was made under Make in India initiative and launched in February 2019. It is an engine less train running from Delhi to Varanasi. Yes, India is in developing stage for self-innovations of engine. And lastly, I would like to show you the great heads of engine who contributed their whole life to make our life easier. So, a great shout out to all of them and many more who made engines and still developing. Now, my friend Vedant would further describe the beginning a new era with engines. Thank you.
Greetings to one and all. I am Vedant Gupta. As Harshika has already introduced you to the topic, I'm going to provide a gist of the major inventions in the world of engines with the scientist's name and the date. The first evidence of the engine dates back to 202 BC, where we can know about the hand-operated cranks which appeared in China during the Han Dynasty. When we move a little forward, during the 9th century, that was changed to hydraulic devices, which has been explained by the Musa brothers in their book of Igneous Devices. The 13th century marked the beginning of a new engine, which is the rocket engine, which has the capacity of internal combustion. The 17th century, the Christian Huygens designs the gunpowder to drive water pumps to supply 3,000 cubic meters of water per day. Most of the development have taken place during the 18th and the 19th century. During 1794, Robert Street built a compressionless engine. He was even able to build an engine which was able to use liquid fuel. The Swiss engineer Francois Isaac de Rivaz, he built an internal combustion engine powered by hydrogen and oxygen mixture. The father of engine, Samuel Brown, patented the first engine in 1823, which was able to be, which can be applied industrially. 1824, Sadi Carnot established the thermodynamic theory of idealized heat engines, which are now the base of major heat engines. Nicholas Otto is famous for his design of the four-stroke engine. Dougal Clerk provided us with the two-stroke engine. Edward Butler in the year 1884 constructed the first petrol internal combustion engine. He also invented the spark plug and the ignition magneto. Carl Benz designed his four-stroke engine, which can be used in automobile. Rudolf Diesel in the year 1892 was the first one to produce a compression ignition engine. He has been famous for the use of diesel as a fuel. The Hellesman engine, introduced by the engineer Jonas Hellesman, represents the first use of direct gasoline injection on a spark ignition engine. Griffith, in his paper Aerodynamics Theory of Turbine Design, he was able to build self-confidence in the jet engines which were previously not having a higher efficiency. The engineers for the Texas company Chevrolet, they developed a four-stroke engine with a fuel injector, and it was known as the Texaco combustion process. In the year 2021, the United Nations Climate Change Conference, 30 states have signed a ban on internal combustion engines. Germany and several other participants did not agree. The Deuce AG presented a new hydrogen zero emission combustion engine in the year 2021. Thank you. Now I would like to hand over the presentation to Anurag.
Thank you, Vedant. Hello, friends. My name is Anurag Tiwari. As my fellow friend Vedant Gupta described the periodic innovation in engine, so in continuation with that, I'm going to light my views on engines in 13th century. Can you ever imagine how much powerful the human brain is? In present era, we are very much friendly with technologies, but in 13th century, what could have been the scenario? It is only the power of human brain that they developed rocket engines. So let's discuss firstly the periodic discovery of rocket engines. At very first, Chinese developed a fire arrows with the help of gunpowder. The Chinese began experimenting with the gunpowder filled tubes. They attached the bamboo tubes to arrows and launched them with bows. Soon they discovered that these gunpowder tubes could launch themselves just by power produced from escaping gases. And finally, the true rocket was born. And in 13th century, the rocket engine, an internal combustion engine, was developed by Chinese, Mongols, and Arabs. Now, the Chinese thought to use these effective arrows in the war with Mongols. The date reporting the first use of true rocket was in 1232. The Chinese repelled the Mongol invaders by a barrage of arrows of flying fire. These fire arrows were a simple form of solid propellant rocket. What is arrows of flying fire? They were as weapon of destruction, and it put psychologically effect on the Mongols along with huge surprise of new invention of weapon. And at last, I would like to conclude the last subtopic of my generation of 13th century. It is innovations in rocket engines. Taking inspiration from Chinese, Mongols produced rockets of their own and may have been responsible for the spread of rockets to Europe. All through the 13th to 15th century, there were reports of many rocket experiments. Roger Bacon, a monk of England, worked on improved form of gunpowder that greatly increased the range of rockets. Jean Froiser of France found that more accurate flights could be achieved by launching rockets through tubes. Johannes di Fontana of Italy designed a surface running rocket powered torpedo for setting enemy ships on fire. These all innovations in rocket further encourage the upcoming brains to design and improve the quality. And at last, that's all from my side. Thank you all for patiently listening me. Now I would like to request Sanya to further continue the presentation with her own views.
Thank you, Anurag. Hello, everyone. I'm Shania Kushwa. It's honor for me to deliver a presentation on a very interesting topic. On continuation with the generation of an engine after 13th century, I would like to draw your attention towards the further innovation of engine in 17th century. In this presentation, I will cover three main topics: gunpowder engine, Huygens engine, Sabry pump engine. Gunpowder engine, it was the first explored during the 17th century. It's an explosion engine. It's a type of an internal combustion engine using a gunpowder as its fuel. In the starting of the 17th century, there was an inventor, Samuel Morland, used gunpowder to drive water pumps. After that, in 1618, the first internal combustion engine created by the scientist Christian Huygens This engine could not be developed into a commercial model due to some problem. In the late 17th century, the first commercial successful steam engine invented by the Thomas Abbey. It's used to pump water out of mines. These all inventions most useful to put a revolutionary base of upcoming technologies. That's all from my side. Now I would request the Christians to further continue the presentation.
Hello everyone, my name is Kshitij Jain and my application number is T003316. I'm glad to be here with you all today. Further moving on in the timeline of engine, we have engine in 18th century. Further, many important events took place in the 18th century, which contributed in development of engine. Steam engine was the first engine that was introduced or invented in the early 18th century. In 1712, Thomas Newcomen's atmospheric engine became the first commercially successful engine. It used the principle of piston and cylinder. It was the fundamental type of steam engine used until the 20th century. The steam engine was used to pump water out of coal mines. It simply used the principle of atmospheric expansion and condensation. It created a vertical beam of motion that was around 10 strokes per minute. Further inventions were in 1794, Robert Street patented an internal combustion engine. It was also the first to use liquid fuel, and it built an engine around that time. In 1798, John Stevens built the first American internal combustion engine. As you can see in the picture itself, this was the first American internal combustion engine. Steam power was revolutionized in the second half of the 18th century through developments pioneered by the engineer James Watt. He introduced smaller and more efficient engines for the first time that produce rotatory motion. Now, moving on to the next slide, we have the Watt engine, which was one of the most remarkable inventions in the 18th century. While repairing a model Newcomen steam engine in 1764, Watt was impressed by its waste of steam. In May 1765, he suddenly came upon the solution. It was the separate condenser, which was his first and greatest invention. Watt had realized that the loss of latent heat was the worst defect of Newcomen engine. The following year, Watt took out the famous patent for a new invented method of lessening the consumption of steam and fuel in fire engines. This was all in the topic engine in 18th century. Now I would like to hand over the PPT to Samay Sagar so that he can continue the presentation further.
Thank you, Kshitij, for giving us a short brief about 18th century engine. Hello, my teammate. This is Samas. I will go to a short explanation of my slide, which I represent now. I will going to explain about 19th century engine. So I start with high pressure steam engine, which was introduced by a Cornish engineer Richard in 1802. Next one is Carnot heat engine. This is introduced in 1824 by Nicholas Carnot. Next with is triple expansion steam engine. This is a compound engine that expands the steam in 3 states, and it was introduced by Daniel in 1861. Now it is time for internal combustion engine, which was created in 1876 by Nikola Otto. By the end of the 19th century, the internal combustion engine was challenging the steam engine in many industrial and transport applications. Thank you. Future presentation goes to Mr. Saurabh.
Hello everyone, my name is Saurabh Tripathi and my application number is T002979. Firstly, thank you Samay for making our audiences familiar with 19th century engines. Now I shall continue the discussion by giving a brief description on how engines evolved from 20th to mid 20th century. In 1900, Rudolf Diesel demonstrated the diesel engine in the 1900 World's Fair using peanut oil fuel. And after 2 years in 1902, Leon Lavoisier, a French power plant aircraft designer and inventor, invents the V8 engine with internal combustion engine configuration, which was initially used for aviation and speedboat propulsion. Then in very next year, in 1903, Aegidius Elling, who is known as father of gas turbine, built a gas turbine using centrifugal compressor, which runs under its own power. This was the first working gas turbine. Then from that year to the 1906, a team of Armen God and Limail in France built a complete gas turbine engine. This engine was so inefficient at about 3% thermal efficiency that the work was abandoned, but it was extended up to 13% thermal efficiency by Hans Holzworth in 1908. Then in 1908, Ernst Godward invented a petrol economizer which worked very well. Then a gap of after 8 years, Auguste Rothew gave the first example of turbocharger, and then after a gap of 9 years, a Swedish engineer, Jonas Hesselman, represented the first use of direct gasoline injection on a spark ignition engine. Then in very next year, in 1926, Alan Arnold published his aerodynamics theory of turbine design, which demonstrated that existing compressors were flying stalled, and the major improvements can be made by redesigning the blades from a flat profile into a airfoil. Then after a 4 year, in 1930, Schmidt patents a pulse jet engines in Germany. Then after 5 years, in 1935, Hans von Ohen and Ernst Hinkel developed a working model of world's first turbojet on a test stand. Then in 1936, a French engineer, René Leduc, successfully demonstrated the world's first operating ramjet. It is a form of air-breathing jet engine. Then after a gap of 10 years, in 1946, Samuel Bayline developed the Bayline engine, a three-cycle internal combustion engine with rotary pistons, a crude but complex example of future Wankel engine. That's it from my side. Now I would like to invite my friend Krishna Mohan to continue this discussion. Thank you.
Thank you. My name is Krishna Mohan and my application number is T003369. Now I am starting my presentation. My topic is modern engine. As the name suggests, modern engines are more efficient than its previously formed engines. They can generate more power without producing harmful gases. They produce less noise and less pollutant. We are now at the age of electric vehicle engines. They are the future of new transportation medium. Generally, modern engines can be categorized in 3 or 4 many types, but generally first based on combustion mode, first internal combustion engine. In ICE converts chemical energy in fuel, heat, energy, but then to mechanical energy to perform useful work. As the figure suggests, system plus fuel air is internal, heat is inside, and also the energy utilized inside. In external combustion engine, the combustion occur outside, heat generate outside and utilized inside. Based on the working operation, it is spark ignition engines or petrol engines or gasoline engines, and compression ignition engines are diesel engines. Based on transportation, land transport engines, water transport engines, air transport engines. Here, from this my side, thank you everyone for being part of my presentation. I will hand it to my team.
Thank you, Krishna Mohan. And now my name is Darshan Agrawal and my application number is T000239. My topic is future aspects of engines. I will be Speaking on this topic broadly on 5 subtopics. My first subtopic is restrictions on CO2 emissions. The Global Carbon Project reported that worldwide carbon dioxide emissions were expected to rise by 4.9% in 2021, nearly back to their record 2019 levels. Emissions plummeted from 2019 to 2020 5.4% as the COVID pandemic brought travel to a near standstill. In August 2021, the US Environmental Protection Agency (EPA) proposed revised greenhouse gas emissions guidelines for passenger cars and trucks in model years 2023 to 2026. The proposed standards include 10% greater emissions improvement than current standards for my 2023 vehicles and 5% greater emissions improvement in each of the following 3 years. Current standards only become 1.5% more stringent each year. Well, my second subtopic is how to increase efficiency of IC engine emissions. The Office of Energy Efficiency and Renewable Energy reports that manufacturers reduced pollutant emissions by more than 99% over a 30-year span. Creative minds accomplish this while maintaining or increasing fuel economy. In addition to gasoline and diesel, manufacturers are studying other ways to increase fuel economy, which are using biodiesel, using other alternative or renewable fuels, combining IC engines with hybrid electric powertrains. Well, my third subtopic is diesel engines versus traditional gasoline engines. When Europeans switched from diesel to gasoline cars, there was a related increase in carbon dioxide emissions. In an unexpected twist, some of today's auto strategies are based around diesel engines. Many big diesel trucks actually create less CO2 emission than some smaller gas-powered vehicles. Reports indicate increased technology has produced diesel-powered engines that can fuel smaller vehicles and provide better gas mileage, lower carbon emission rates, greater torque, a longer lasting engine. Fourth subtopic is battery electric vehicles versus internal combustion engine vehicles. You knew this was coming. Although gasoline powered engines don't appear to be completely disappearing, they do face stiff competition from their electric rivals. One thing IC engine supporters could always hang over the heads of the pro electric crowd was the battery, specifically its size, cost, longevity, charging capabilities, or lack thereof. Fifth subtopic is powder metallurgy supports the move to eco-friendly. The green technology, that is powder metallurgy, goes hand in hand with the future of the eco-friendly automobile. Sintered soft magnetic materials with higher densities are providing a boost in performance not seen before. You may have heard the story of powder metal before, but these new materials are different from the standard 35 materials that manufacturers have relied on for decades. Many components can be transitions to powder metal. Powder metallurgy has made great advances in creating small parts for electric motors and other auto parts for many reasons, which are reduces weight, improves electric motor efficiency, including better magnetic properties, creates net shape parts, allows for advanced materials and processes, higher strength and hardness. Thank you.
Warm welcome to one and all. I am Shivam Yadav, the team leader of Group 7. I am here to conclude all the things which was presented by my teammates. Friends, you must have seen a lot of invention, but can you even imagine the engine at that time? I know, my friends, many of you do not have any answer, but it has happened. We invented the engine and made a revolutionary start. So friend, let's get started. In 13th century, the true rocket engine developed by Chinese. In 15th century, we moved toward the compression engine. In 18th century, we developed an internal combustion engine based on Nicholas Otto. In 20th and 21st century, we developed the modern engine. Many modern engine. So let's move to the second slide. My second slide is about pros and cons of engine. So firstly, we discuss about pros. Engine used in daily life such as healthcare, agriculture, industries, and many more sectors. Let's move to the cons. It has cut down the employment of many people. You know very well, many people are unemployed due to engines. And one more thing is environment is harmed so badly due to engines. So let's move to the third slide. Third slide is about ideas, innovations, and futures of engine. So we discussed about the ideas and innovation and futures of engine. Firstly, we discuss about the advanced engine. Advanced engine are V8 engine, V6 engine, and many more. And one more very important about engine is the engine should be made eco-friendly. So thank you for your patience. I hope you enjoy our presentation. Thank you again. Have a good day.